Terry is going to talk about the large-scale modeling methods after I am finished, but I just thought I'd give a little background to how this is done manually, either for studies that are so small that the model would just be overkill or even inaccurate or even make no sense. You have this development and you take a look at where the economic and population activity is. Like, this is what they call desire lines. The thicker the line, the thicker the arrow. It's based on usually a person's knowledge of the area, census data. The next few slides were taken from the era before the big use of computers. And this is, so you can see, this is like a hand-drawn development, and it's explaining where the trips from this development was going. And usually, together with the people who are going to review it and the people who are developing the site, they decide on the major directions. And this just shows what happens after you fill this in. You can tell this was all done by hand drawing. So this is pre-computer. Now this is from a traffic study from Miami that used a manual distribution of traffic, but in order to get its distribution, the major distribution, they went to the model, the Miami-Dade model, and got cardinal directions from the model, and then from that they distributed the traffic. This was for a Walmart. Distributions that you've created that everybody's agreed upon for the year 2008, let's say, can change. And they can change dramatically. Here's a network where people agreed to the distributions. They also agreed to where the trips will be going and coming from. But in the period from the first period study analysis to the second or third analysis, there was a brand new interchange. And that is going to change the distribution of travel dramatically. If you're doing a manual distribution of traffic, there's the concept of trip attenuation, which means that when a trip leaves your site, the site that you're studying, it doesn't go 100 miles usually. You got 100 people leaving it, and the further you get from your site, the more those trips, either they're gone home or they've gone someplace else. So the number of trips that leave your site as it gets away from your site, and you'll see it graphically much better when Terry does his presentation, reduces itself. What they're called the intervening opportunities when the trip ends. How do you figure this out? One way to do it is, this is a trip length frequency diagram from a model of a particular urbanized area. It's for different uses of trips, but it can be combined and simplified if you're doing a manual distribution. This is an overly simplified example here that if your average arterial speed is 18 miles an hour, then if you go 2 minutes using the trip length that they got from this town, 5% of your trips drop away. Then 4 minutes out, 15% of your trips go away. And then 10 minutes or 3 miles out, 50%. These are just examples. This isn't a particularly real one. So you got 100 trips going here, but 5% drop out. That's 95. You get to this corner, 20% make a turn. And if you had no attenuation, there would now be 20. But really at this point you are 15%, you're like 0.6 miles and 0.6 miles, you're now just 17 trips. You get to this decision point, 20% went this way, 20% that way, and now you only have 10 trips going. Now, if you were not attenuated, you'd have 12. But now that you've dropped another a cumulative 30%, you're down to 8. The important thing, however, is that this decision is one of those decisions that you go through during your initial meeting between the reviewers and the people doing the analysis. This just shows the principle here. I'm going to show one example of how this works, and we'll simplify it. This is the office in that development. There were 670 external trips, and they actually came from the last PowerPoint presentation before tips. And we see those cardinal directions. And then we also have the percentage entering and exiting that we get from the ITE trip generation report. Now, these things, like what percentage are going in these cardinal directions, many times is professional judgment. So you just keep working out, and you end up with these numbers if you were to work it out. Now, we are just going to take one of these. This is just the office. And there's no easy way around it. There's a lot of manual work and keeping the numbers straight in a spreadsheet. We're going to look at these 278 exiting trips from the office. And again, professional judgment, because the office complex is fairly large with two major access points. That 167, again, professional judgment went this way, and 111 are going to meet them going that way. Is actually a combination of retail and those apartments. This is similar to those desire lines that we were talking about. They're thick, where the most impact is, right near the site, and it goes down as the further away you get from the site. And we look at, back up, one intersection just north of the site where those trips meet. You add it to the background traffic. And I'm just going through this. This is, I can't say it's simple because it's tedious. But the development traffic is added to the background traffic. And then you have to figure out, or you have to make a judgment of where the traffic turns. Now, ideally, and it should be more than ideally, anything this large, you will have had turning count studies being done at the major intersections. So you have an idea of where travel is changing at this intersection. Sometimes you're expecting it to change in the future, other times you may expect it to remain the same. So you see in this case, we had 62% of the 1,258 development trips going north. Then we have that background of 742 and 780 equaling 1522. And you do the same for the other direction. Now you have all the numbers added together, and that's where you do your basic level of service analysis. You now have turning volumes, which you can use the highway capacity manual software to look at the intersection. Sorry that went so quick, but I'm trying to just give you the idea of the concept there.